You're welcome back to our AutoCAD training workshop. I'm glad to have you once again. In our last workshop, we looked at the line command, the construction line, the polyline, the polygon, and we actually ended up at polygon. We are beginning from the rectangle tool in the draw toolbar. We saw how to use lines, we saw how to use construction line, we saw how to use polyline, and we also saw that we can use the line command to draw a rectangle. We can also use the polyline command to draw a rectangle. While the polyline is continuous, series of joined lines, the line tool is discontinuous. Today we are going to look at how to use a rectangle tool to draw a rectangle. Like I've said before, we have earlier looked at how to use line command and polyline command to draw rectangles, and that's what you can see on the slide. This is polyline and this is line. Line is continuous, while polyline is discontinuous. Now a rectangle has two coordinates, x and y coordinates, with a horizontal start point. Okay, this is the x coordinate, then this is the y coordinate, aligning with our x and y axis of this UCS. Now there's a start point and then there's an end point. When you take the rectangle tool from the draw toolbar, the software will ask you to specify your start point. When you click on your start point, all you need to do is to type in the x and y coordinates of the rectangle, separated with comma, and hit enter, and your rectangle will come out. So let's proceed to do that. We still use the dimension of 10,000 by 5,000 that this rectangle has here. So I clicked on my rectangle tool, look at that, specify first corner point, specify here as my first corner point, drag out my crosshair, and then type in my xy coordinate 10,000, 5,000, and hit enter. Okay, I think this is actually 5,000, 2005, but this one we drew is 10,000, 5,000. That is why it's bigger. Okay, so this is our rectangle of 10,000, 5,000. Let's also take the one of 5,000, 2005. I repeat my rectangle tool, I specify my start point, I type in my coordinate of 5,000, 2005, and I hit on enter, and I have my rectangle. So it's exactly the same as what we have here because they are the same dimensions. So that is how the rectangle tool works. The next tool after the rectangle tool is arc tool. Now, what is an arc? An arc is just a part of a circle, and like a circle, it takes center point and radius or diameter. Now AutoCAD draws an arc using 3 points, as you can see in the preview of the tool. You have first point, second point, and then third point. Now let me quickly draw a rough arc. I click on the arc tool, look at that, it's asking me to specify start point, and I specify second point, and then I specify last point, and the arc comes out. So this is a rough arc. Now if we want to draw a well-dimensioned arc, we need to use lines to bring out our 3 points to draw the arc. For example, I want to draw a semicircular arc of diameter 1,800 and radius 900. You know the diameter is twice the radius, or radius is half of diameter. So I take my line command, I draw a line of 1,800, and then from the middle line I draw another line of 900. Remember, the diameter is 1,800 and the radius is 900. Sorry. So I pick up my arc, I have my first point, I have my second point, and then I have my last point, and the arc comes out. I can remove off this line, this construction line, just select it and hit delete on your keyboard. So this is our semicircular arc of radius 900 and diameter 1800. So assuming I want to draw a quarter circular arc, that is, if you share a circle into 4 parts, one part of it, that's what we mean by quarter circular arc, of radius 900, all I need to do is take a line command, 900, enter, another 900, enter. Now we have established earlier that an arc is drawn using 3 points. We just have 2 points here. Now we need another point at the middle here, a line of 900 at an angle of 45 degrees. So all I need to do is just to track my angle. Can you see on the screen angle 45? Then what you need to do next is to type 900. So this is a line of 900 at an angle of 45 degrees. So you can actually take a sliding line and track the angle. Can you see that? That's angle 60, 60, 52, 51, just like that. And this is 45. And then if you have an inclined line at an angle, for example, a 2000 mm line at an angle of 45 degrees, all you need to do after tracking your angle is to type in the magnitude of the line, which is 2000. Okay, so that was how we got this line. This line is a line of 900 and an angle of 45 degrees. So I click on my arc, take it as my start point, second point, and then of course last point. This is just a construction line which you can delete off, or if you want to leave it there, you can let it be. This quarter circular arc we just drew is actually how doors are represented on building floor plans. So that is how the arc tool works. You can draw any kind of arc you want to draw, provided you know what the arc is. I mean, you know the radius of the arc or the diameter of the arc, and then you just construct lines and bring out the arc that you want to bring out. Any type of arc can be drawn. Then very quickly, the next tool is circle. Now, just like an arc, a circle takes 2 parameters. You specify the center point and you enter either the radius or the diameter. By default, AutoCAD will usually ask you for radius, but if you want to use diameter, then you can select the diameter option. Good. So now when we click on the circle tool, it tells you to specify center point of circle. Now if you have indicated the center point before, like what we have here, if you have made out a center point before, all you need to do is to click on it. So let's use it as our center point and click on the center point, and you see the circle coming out. The next thing is to ask you to specify radius of circle. Can you see that? So let's specify 1000 as our radius and enter. So this is a circle of radius 1000. Of course, you know that the radius is 1000 and the diameter is 2000. So this is how AutoCAD draws circle. Then the next tool is Revcloud. Now Revcloud is used to single out a portion of a drawing for analysis. Like what you can see in the preview there, you can see the Revcloud there drawn in red. That portion of the drawing has been singled out for analysis or further detailed drawing. Now that portion of the drawing there can now be made bigger so that the entire details can show in another drawing, of which this particular singled out portion will be referred to. For example, you can write detail A there, and then in another drawing you will now draw detail A in an expanded form where all the details of that particular place can now be shown. So how does Revcloud goes? You click on Revcloud. For example, I want to single out this place and make it and expand it in another drawing. So all I need to do is to specify start point, as you can see right there, and just begin to drag my cursor. After you specify this start point by clicking, and then you release your mouse and then just begin to drag, and what you see is this guy coming out. You double click and then you enter twice for the Revcloud to come up. So I've singled out this portion for analysis. Now you can also use Revcloud to draw clouds on top of building elevations. Using the same way the Revcloud can be drawn. You get to your endpoint, you double click and then enter twice. Just keep on drawing the clouds of different shape. You see, it looks like a cloud on top of building elevations. So that's how Revcloud works. And then spline. Splines are curved lines. As you can see in the preview, they are drawn using points. You can see the blue points in the preview. You indicate those points by clicking. So let me take on the spline tool, say specify start point, and go on and just be specifying points. Just be specifying points to bring out my spline. You double click and then you enter twice to terminate the spline tool. In topographic maps showing features of terrain, splines are usually used to draw rivers. You know, you see something like this in huge topographic maps for rivers. Double click and enter twice to terminate. You then see another one. Double click and then enter twice, terminate. Good. In large topographic maps, you see this. They are used to represent rivers in a particular terrain. If you have rivers, you have other features like forest and all of that. When you see this, when you see what is on the screen now, you know that this particular portion of the terrain is a river. And then you can also use spline to indicate cuts in pipes. For example, you would have seen some piping drawings that have something like this. Let me pick on my spline tool. Okay. Good. So you have seen something like this on pipes, indicating that this pipe is cut here as it continues. Yeah, you use the spline tool to do this. So you take the spline tool, you click, you begin to click the points you need. After that, you click twice and enter twice to terminate the command. Now you can also adjust the spline using the grips, the points with which you used to draw it. You see this point 1, this point 2, this point 3. So now if I want to, I can adjust this spline by clicking on this point. When I see the red color of the grip comes up, I'll release my click and then I'll begin to adjust, drag down. It can be adjusted, yeah. And then you click and tap on escape to terminate the selection or the highlight. I can also adjust this, can adjust this down, can also adjust this and all of that. So that is how to play around with the spline. So that is how spline works. Now the next tool is ellipse. Now what is an ellipse? An ellipse is just a compressed circle or a tilted circle. Now you draw a circle like what we saw before. You draw a circle using center point and a radius, but an ellipse has been compressed or tilted, so we no longer have a center point and a radius, but what we have now is a center point and a major and a minor axis. Let me quickly draw a rough ellipse to buttress what I'm saying. Okay, this is a rough ellipse. Now you can see that it looks like it's actually a compressed circle, looks like an egg. Okay, So this is the minor axis, the shorter side, and then this is the major axis, the longer side, and then where they intersect is this center point here. So if you want to draw a word dimension ellipse, we will start by using this center point. So when you click on the ellipse command, you have several options to draw it, among which is the center point. So on your keyboard, you type C, which indicates center point, and then hit enter, and then you start drawing the ellipse from the center point. After that, do not enter the distance to the major axis and the distance to the minor axis if you want the longer side to be in the major axis. But if you want the longer side to be in the minor axis, then you start your drawing by entering the minor axis first before entering the major axis. What I'm trying to say is this: if you want the longer side of the ellipse to be in this side, that is the X side, look at your UCS, XY. If you want the longer side to be along this, then you enter it as your first distance, which represents X. Then if you want the longer side to be on the Y side, you enter it second, so that it will be this way. What I'm trying to say is, any dimension you enter first is for X, corresponding to X here. Then any dimension you enter last will be for Y, corresponding to the Y here. Very good. So I click on my ellipse. When I click on my ellipse, you can see the center point option here. So you can type C for that, enter. Now ask you to specify center point. I click to specify my center point, and I drag out my crosshair. You will see something like a line wanting to come out. Now, if you have the distance from here to be 1800, and you are starting your drawing from here, you are here right now, center point, you know, type C, enter. That means if you want to enter distance from here to here, you have to enter 900, right? Because 900 is half of 1800. So I enter 900. Okay, now if I have here to here as 1008 and here to here as 900, and I have here to here as 9, let me say here to here, from here down to here is 700. That means from the middle, remember we are at the middle, from the middle or at the center point, from the center point to the end of this, to the end of this minor axis will now be 350, since the entire one is 700. So I type 350 and hit enter, and that's it. That's my ellipse. This ellipse you are seeing right here now, this major axis is 900, and of course this minor axis is 700. That is what you have for that ellipse there. Remember, we started drawing from the middle, so from the middle to here is 450, while from this middle to here is 300. But the entire one here to here is 900, and then here to here is 700. So that is how the ellipse to work. So very quickly, let me take another ellipse. This time around, the entire major axis will be 2000, while the minor axis will be 1000. But this time around, I want to shift the major axis to the Y, and then the minor axis I want to put on the X. So let's go. I click on my ellipse, type C, enter, choose my center point. It's asking me to specify distance to one of the axes. Now, like I said before, I want my major axis to be Y, so the lower number will be for X. I will enter 1000, enter, then I will enter 2000, enter. So this is it. Now what I'm supposed to do, I'm supposed to enter 500 and 1000, because I actually entered the full length of the major axis and the minor axis. As it is now, if you dimension here to here, what you have is 4000. If you dimension here to here, what you have is 2000, because I actually entered 1000 this way, then 2000 this way. But you know, I'm actually from the middle, So from the middle to here is 2000, and here to here is 2000. So the entire one will be 4000. Now let me draw with 500 and 1000 so that you can understand what I'm saying. It will be half of this. So I type C, enter, specify my center point. This is 500, enter. Then this is 1000, enter. Good. So what I'm now saying is I'm at the midpoint now. From here to here is 1000, so the whole is 2000. Then from here to here is 500, so the whole is 1000. You see it's slightly bigger than this because this is 900 to 700, while this one is 1000 to, sorry, why this one is yeah, this one is 1000 to, sorry, this one is 2000 to 1000. Yeah. So the very next tool is ellipse arc. Now an ellipse arc is drawn using all the steps you use in drawing an ellipse. All the steps we use in drawing an ellipse now, you use them in drawing an ellipse arc. But by the time you enter the distance to the last axis, you now need to enter a start angle and an end angle. Now an ellipse arc is also an arc, but it's an arc derived from an ellipse. Just like you derive a normal arc from a circle, like what we said before, that an arc is part of a circle in our earlier tutorial when we were drawing arc. Now an ellipse arc is also part of an ellipse. So you take the ellipse arc command, you type C, enter, you specify your center point, you enter the distance to the two axes, and then you enter a start angle and an end angle in order to get your ellipse arc. Now if you want to do that, look at this. Let me explain something with these 4 cardinal points in order to get the understanding of the angle. Now we know that this is 90, this is 0, this is 90, this is 180, this is 270, and then this is 360. Now let me take my test 2. Let me just fast forward. I want to write some tests. We have need for it now. This is okay. So just want to quickly do this so that we can understand the concept of angles. $90, 180, 180, 270, and then of course 360. I just want to explain the concept of start angle and end angle that we'll soon see when we are using ellipse arc to draw an arc. Now you know our 4 cardinal points. 0 starts from here. As you are proceeding right here, you get to 90. As you are proceeding right here, you get to 180. That's why we say angle on a straight line is 180. As you are proceeding here, you get to 270, and when you hit here back, you would have gotten to 360. You have completed an entire circle. Now if you have an ellipse arc like this, good. If you have an ellipse arc like this, let's say the ellipse arc is hits here and then terminates here, you know that this ellipse arc, the start angle of this ellipse arc is 0 degree, while the end angle is 90 degrees. You know that. Then if you have your ellipse arc like this, you know that the start angle of this ellipse arc is 0 degree, and then the end angle is 180 degrees. But if you have your ellipse arc like this, let's assume you have your ellipse arc like this. Sorry. Actually want to bring it back. Okay, let's delete all this ellipse arc and take a fresh one. Assuming you have your ellipse arc somewhere like this, you know that this ellipse arc, the start angle is somewhere at 10 degrees, and then the end angle is somewhere at 65, 70 degrees. You see, it is between 0 and 90 degrees. So that is just a concept of start angle and end angle for an ellipse arc. So let us take the ellipse arc 2. Now, as usual, we type C, enter, to indicate our center point. Click here as our center point. Now we specify the distances to the two axes. Let's assume we want to draw an ellipse arc of measure distance, distance to major axis 900, and then distance to minor axis 900. Let's assume we want to draw an ellipse arc of that type. The distance to the major axis and the minor axis are equal. So since we have the major axis distance as 900, the minor axis distance as 900, and we are drawing from the center point, that means the distance to the two axes will be 450, 450. So I type in 450, enter. Type in 450 again, enter. Distance to my axis. If you look at now, it's asking us to specify start angle. Like I've said before, ellipse arc will request us to enter a start angle and an end angle. Unlike an ellipse, if we are drawing an ellipse now, immediately we enter the distances to the two axes, the major axis and the minor axis. The ellipse will just come out and the command will automatically terminate. But since we are drawing an ellipse arc, it is asking us to enter the distances. It's asking us to enter the start angle and the end angle. So let's enter a start angle of 0 and then end angle of 90, and that's it. That's our ellipse arc. So you are having exactly what we have here. This is 0 and then this is 90. If you draw your 4 cardinal points, you'll see what we are talking about. So this is it. So you can see that it is starting from 0 and terminating at 90 degrees. Now you can equally draw a semicircular arc that will start from 0 and terminate at 180 degrees. So I take my ellipse arc, I type C, enter, I click to specify my start points. Assuming we have distance to major axis as 1800 and distance to minor axis as 1800. So since we are starting from the middle, we'll enter 900, 900, 900, enter, 900, enter. Now to ask us to specify start angle 0, enter. Now end angle 180, enter. So that's it. That's it. It will give you a semicircular arc. So that is how the ellipse arc 2 works. Thank you very much for participating in this workshop. We'll see you in the next workshop where we will start from insert block.